Welcome back to another great day of calculus. Today we're going to be talking about exponential functions. So today we're just going to be talking about the parent function, which is just y equals b to the x, or f of x is equal to b to the x, which is going to mean that b is my base, and that to the x just is going to be my exponent. So if b is larger than 1, then it is going to be an exponential growth, which means that it's getting bigger and bigger and bigger really fast. And if b is in between 0 and 1, it is actually going to be an exponential decay. Other than that, we're actually going to be looking more at exponential growth and decay models, which actually means that we have an a out in front of our parent function of b to the x. All that a does is it's actually going to either cause a stretch or a shrink vertically. And that's about the only difference from pre-calculus into now, is that we're going to be dealing with a lot quote-unquote worse looking functions. Okay, so sketch the following as accurately as possible on the graph below. So we got g of x is equal to 2 times the quantity of 3 to the x. So does this show a growth or a decay? So the easiest way to look at this is you literally look at that number that to the x is attached to. If it is bigger than 1, it is a growth. If it is in between 0 and 1, then it is a decay. So in this case, it is a growth. Alright, so now we just need to graph this. So graphing this, probably the fastest way, make a t-chart. When in doubt, t-chart it out. So we got an x column, we got a y column, we got what? -1, 0, and 1 is probably the easiest. So plugging in -1, I get 2 times 3 to the -1. Remember, in order to get rid of this negative exponent, we've got to flip it over the fraction line to change the sign of the exponent. So I'd actually have 2 times 1 now over 3 to the +1, because I still got to have a placeholder up top, which all in all will give me 2/3. Alright, to the 0th, so I've got 2 times 3 to the 0th power. Anything to the 0 power is 1. So we got just 2. And then we're going to have 2 times 3 to the 1st power, which is just going to be 6. So graphing this, I should have -1 2/3. I've got 0 2. I've got 1 6. 6. Cool. And so now I just connect the dots. And I should be golden. So my domain, which means that my x values, I can plug in negative numbers into my exponent. All that negative numbers are going to do is make this a smaller and smaller fraction. So all that's going to do is get this line closer and closer and closer and closer to this x-axis, but it's never actually going to touch going off to the left. It's going to get really, really close, but never actually cross or touch that x-axis. So my domain should be all real numbers, or -infinity to +infinity should be that domain. Versus my range, well, I am never going to touch that x-axis, which means that my y values are never going to get past 0. But going to the right, I see that my y values are getting larger and larger and larger really, really fast, which means that my range is going from really, really close to 0, so 0 is not included, all the way up to infinity. Easy as that. Alright, so the next thing that we're going to look at is this exponential growth problem. So what's happening here is we have a collectible that we bought for $150, and it says the collectible increases by a value of 3% each month. How much is it going to be worth in 2 years? Well, way back in the day, we had this equation in Algebra 2 and maybe pre-calculus. I don't remember if we got to it last year or not. But what that equation looked like was y is equal to the principal amount, which is just the initial amount, times 1 plus the rate to the amount of time. So In this particular case, my principal is just that 150 times 1 now plus my rate, because it's increasing every single time by 3%, which as a decimal is 0.03. I don't know why my decimal just disappeared, but that's all right. To the t, well, it says in 2 years, but it's also increasing each month. So in terms of months, 2 years would be 24. All right, and then plugging this all into a calculator, I would get approximately $304.92. And that's it. That's all. All right, so what if instead it decreased by 2% each month? How much is it going to be worth in the first year? Well, this time, instead of adding my rate, it's decreasing each month. So I'd actually have to take 1 minus 0.02, which would just leave me at 0.98. That's about the only difference. So my principal was still 150. But this time, instead of it being 2 years, it's 1 year, still measured in months. So it should be t being 12 this time around. All right, plug that into a calculator. I should get 117.71, I think. And like that, I'm done with that particular problem. All right, so the next part should be pretty nice, pretty straightforward. The first thing that this question asks for is the initial amount. So it says, suppose we invested $12,000 in an account that earns us 5% interest compounded monthly for 10 years. So the initial amount is what we invested, that $12,000. So that's going to be my A. My growth rate, that's a little bit trickier. That still looks like that 1 plus R, but this time my R is going to be divided by the number of months I have. So that's usually represented by N. If it lets me write an N, I guess not. Cool. And then that's it for that. So just plugging that in, I would get 1 plus R, which is that 0.05, because 5% as a decimal is that 0.05, divided by the number of months. So it says 10 months. Excuse me, it says per monthly, so that's just 12 months in a year. I misread that for a second. All right, so how many times does this money grow in 10 years? How many times is this interest added to our account? So it says, hey, it's growing for 10 entire years, so that's monthly. So 12 times that 10 years, which would give us 120. So now it asks us, how much money will I have in 10 years? So all I'm going to do is put this all together. So I've got y is equal to a times that 1 plus r over n now to the t. This could also be a p here as well, not just an a. You can see it as either or. Just want to point that out. I realized that I called it a earlier in this particular problem. So plugging this all in, I get y is equal to now 12,000 times 1 plus r, which is that 0.05 that we plugged in earlier, divided by the amount of months in a year, which is 12. All of that to how many times it's growing per year, my time, which is that 120. Plug this all into a calculator, because if you can do this in your head, well, why can you do this in your head? That's my first question. I mean, it's talent, but also just why? All in all, I should get $19,764.11. That should be it. Thank you for joining me. I will see you tomorrow. Have a great rest of your day.